Next chapter is Yale hospital rule and successive differentiation. That is second order, third order, nth order derivative. So the first point is Yale hospital rule. So first is the indeterminate forms. So 0 by 0 and infinity by infinity are the two basic indeterminate form. Indeterminate forms means what? 0 by 0. No one know the value of this 0 by 0. Infinity by infinity. These are indeterminate forms. Still, the value of 0 by 0 is not determined by any mathematician. That is, 0 by 0 is value is either 1 or infinity or 0, because we know the rule of the division, some rules of divisions. What are that? The division of similar number is 1. So that's why 0 by 0 is maybe 1, maybe 1. Or we know the rule that if we divide 0 by any number, that is 0 by 5 is 0, 0 by 9 is 0, like that 0 by 0 is 0, and anything divided by 0 is infinity. That is 5 by 0 is infinity, 6 by 0 is infinity. So 0 by 0 may be infinity, but no one can find the value of 0 by 0 or infinity by that. These are the indeterminate forms. These two are the basic indeterminate forms, 0 by 0 and infinity by infinity. Similarly, infinity minus infinity, these are some indeterminate forms. Infinity minus infinity, 0 raised to infinity, infinity raised to 0, 0 into infinity, 1 raised to infinity, 0 raised to 0, and infinity raised to 0. These are the indeterminate forms. So next point is Yale hospital rule. So 0 by 0 form. There are two forms, 0 by 0 form and infinity by infinity form. So statement is also important. Let a limit extends to a fx is equal to 0 and limit extends to a gx is 0. Then limit extends to a f dash x divided by g dash x is equal to L implies limit extends to a fx by gx is equal to L. That is, limit extends to a f dash x divided by g dash x is equal to limit extends to a fx divided by gx. Actually, this f dash x divided by g dash x is not derivative of fx by gx. We know that the derivative of fx by gx is by unit rule, it is gx into f dash x minus fx into g dash x divided by g dash x divided by gx square. But it is not the derivative. It is the derivative of numerator separately. That is fx differentiate this fx separately. That is f dash x, and separately differentiate gx, g dash x. So if the limit of fx by gx separately, if the limit of fx is 0 as x tends to a and limit of gx is equal to 0, then limit of f dash x tends to a of f dash x by g dash x and limit of as x tends to a of fx by gx both are same. So this is the Yale hospital rule. That is, we can differentiate numerator and denominator separately, but the limit remains same. Okay, so you can use this fact to find the limit of the some function. Then next is infinity by infinity form. So limit extends to a fx is infinity and limit extends to a gx is infinity. Then limit extends to a f dash x divided by g dash x is equal to L implies limit extends to a fx by gx is also L. Okay, so solve the example on the L hospital rule. So limit extends to 2x square minus 2 by x minus 2. We have to solve the limit extends to 2x square minus 4 divided by x minus 2. So if we substitute x as 2, the numerator and denominator, what we have, x square is 2 square is 4 minus 4, that is 0 answer, and divided by 0. So we have the answer 0 by 0. So we can apply Yale hospital rule. That is, find the derivative of x square minus 4 as 2x and x minus 2 as 1, and take their equal to sign. Limit extends to 2 equal to limit extends to 2x divided by 1 by Yale hospital rule, because if the limit of numerator is 0, limit of denominator is 0, then limit of f dash x by g dash x and limit of fx by gx are both are same, both are L. means both are same. So this is actually fx divided by gx, and this is what f dash x divided by g dash x, and we have equal to sign here. We have the equal to sign, that is limit x tends to 2 of fx by gx is equal to limit x tends to 2 f dash x divided by g dash x. So actually this is 2x by 1 is not derivative of this quantity. It is the derivative of numerator and denominator separately. X square minus 4 derivative is 2x, x minus 2 derivative. So by L'Hospital rule. And then substitute x as 2, we have the answer 4. 4 by 1 means 4. So okay. So we can also solve this problem in another method by using your 12th science method. What is that? Factorize this x square minus 4. What is the factorization? X minus 2 into x plus 2. Then get cancel x minus 2. We have x plus 2, and then substitute x as 2. We have 2 plus 2 as 4 answer. But no need of this. So the very standard rule that x limit theta tends to 0 sin theta by theta, or limit x tends to 0 sin x by x is 1. We know the rule, limit x tends to 0 sin x by x is 1. So how we can prove the proof of this rule? Limit x tends to 0 sin x by x. If you substitute 0 x as 0, then sin 0 is 0, and 0 by 0 is indeterminate form, and by using L'Hospital rule we have is equal to limit x tends to 0, then find the derivative of sin x is cos x, and derivative of x is 1. Okay, by L'Hospital rule, because what is the L'Hospital rule? Limit of fx by gx is equal to limit of f dash x divided by g dash x. And what is cos 0 now? Substitute x as 0, so cos 0 by 1, and cos 0 is 1, so 1 by 1 answer is 1. So very short method in the we can solve this problem. That's limit x tends to 0 sin x by x is equal to 1, or limit theta tends to 0 sin theta by theta is 1. Okay, so next example, evaluate limit x tends to 0 x square plus 2 cos x minus 2 divided by x into sin cube x. Okay, so we can directly apply L'Hospital rule and solve this example, or we can adjust like this. If we directly apply the L'Hospital rule, then we have some complication in the calculation. So first write x square plus 2 cos x minus 2 divided by x into sin cube x as this. X square plus 2 cos x minus 2 divided by separate this sin cube x into divided by sin cube x, and multiply by x cube and divide by x cube. So x into x cube, here we have x into x cube, x into x cube, x is already there. So write x cube multiply by x cube divide by x cube, and this divided by sin cube. And we know that limit theta tends to 0, theta by sin theta is 1. And so this x cube by sin cube x is what? X by sin bracket cube. That is the derivative is what? Its limit is what? 1 cube. Because x divided by sin x divided by sin x limit is 1, and so it's 1 cube. And so we have x raised to 4. And now we have the now if we substitute x as 0, then what we have? X 0 square is 0. 2 cos 0 is 1. So 2 minus 2 0 divided by 0 raised to 4 is 0. So this is 0 is in the form 0 by 0. So apply L'Hospital rule. So next step is limit x tends to 0. X square, derivative of x square is 2x, and derivative of cos x is minus sin x. So minus 2 sin x. Derivative of minus 2 is 0. Derivative of x raised to 4 is 4x cube by L'Hospital rule. Okay. So again, if you substitute x is 0, then we have 2 into 0 is 0, sin 0 is 0. So numerator is 0, and 0 cube is 0. So 0 by 0 form, again apply L'Hospital rule. So 2x derivative is 2 minus 2 sin x derivative is cos x. Okay, divided by 12x square as the derivative of this quantity. If we again substitute x as 0, then we have 2 minus 2 cos 0 is 1. So 2 minus 2 is 0, and 0 square is 0. So 0 by 0, again apply L'Hospital rule. By L'Hospital rule, limit x tends to 0, and the 2 derivative of 2 is 0, minus 2 cos x derivative is minus sin x. So minus minus become plus 2 sin x divided by 24x. And if we substitute again 0, x as 0, then sin 0 is 0, and 24 into 0 is 0. So again 0 by 0 form. So again apply L'Hospital rule. So we have limit x tends to 0, 2 sin x derivative is cos x, derivative of 24x is 24. So here write it right here by yellow hospital rule. And then substitute x as 0. What we have? Cos 0 is 1. So we have the answer 2 by 24, that is 1 by 12. So this is the example. If we directly apply the Euler hospital rule, then the derivative of x into sine cube x, this derivative, the derivative of this x into sine cube x is this, and then again the derivative becomes complicated. The derivative becomes complicated. So adjust, don't directly use, don't directly use this L hospital rule. Uh, some adjustment is there. So multiply by x cube and divide. So this sine cube x becomes 1 cube, the integral limit 1 cube, and therefore 1. So don't use directly L hospital rule. This function, cancel this function sine cube x by using this rule, and then apply Euler hospital rule. So totally we have to apply Euler hospital rule 5 times, suppose 1, 2, 3, 4, 4 times, and then we have this answer 1 by 12. So next example on the same rule, limit x tends to 0, log sin x divided by cot x. If we substitute x as 0, then sin 0 is 0, log 0 is 0, and then limit x, log 0 is infinity, and log cot 0, cot 0 is cot 0 by sin 0, that is 1 by 0 is infinity. So log 0 is infinity, log 0 is infinity. So we have the infinity by infinity form. Log 0 is infinity, sin 0 is 0. So we have the infinity by, here write in bracket infinity by infinity form is equal to. So next step is equal to apply L hospital rule. By L hospital rule, when we can apply L hospital rule, if the problem is in the form 0 by 0 or infinity by infinity. So this problem is in the form infinity by infinity. So log sin x derivative 1 by sin x into cos x, cot x derivative minus cos x square x. So we have uh, cos x divided by sin x means cot x, and its derivative is minus cos x square x. Again apply L hospital rule, because we have again 0 by 0 form. So we apply again L hospital rule. Cos x by sin x means cot x, its derivative is minus cos x square x, and derivative of minus cos x square x is what? Minus sin, as it is 2 cosec x into derivative of cosec x is minus cosec x into cot x. So minus minus become plus, minus cosec x into cot x. Derivative of 2 cosec square x is what? Cosec square x is what? 2 cosec x, 2 cosec x into derivative of cosec x is what? Minus cosec x into cot x. So minus 1 become plus, and then minus cosec square x get cancelled. So we have minus 2 by minus 1 by 2 cosec x into cot x, and that is equal to limit x tends to 0, and cosec x means into sin x, and cot x means cos x by sin x, means into sin x by cos x. If you write 1 divided by, right here 1 divided by cosec x is into sin x, 1 by cosec x means cosec x means 1 by cosec x means into sin x, and divided by cot x means cos x by sin x, so it is sin x by cos x. So we have, I think, sin x by cos x, sin x into sin x. So we have sin x into cos x, and then substitute x at 0, we have the answer cos 0 is 1, sin 0 is 0. So 1 into 0 is 0. So the answer of this problem is 0. Cosec x means this minus 1 half quantity, minus 1 half, right, minus 1 half, and divided by cosec x means into sin x, and cot x means, so it is sin square x by sin square x into cos x, and I think again the answer is 0. So next problem, the 6 problems for assignment. limit x tends to 0, a raised to x divided by b raised to x minus 1, a raised to x minus 1 divided by b raised to x minus 1. So if we substitute x at 0, then a raised to 0 is 1. So 1 minus 1 divided by b raised to 0 is 1, 1 minus 1, that is 0 by 0 form. So apply Yale hospital rule, limit x tends to 0. The derivative of a raised to x is what? A raised to x into log a minus 1 derivative is 0. And the derivative of b raised to x is b raised to x into log b. So write here comma by Yale hospital rule. And then substitute x as 0. So a raised to 0 is 1, log a as it is, and b raised to 0 is 1, log b as it is. So answer is what? Log a by log b is the answer of this problem. Next problem is limit x tends to 0, x into this quantity, x into e raised to x minus log 1 plus x by x square. This is the problem for homework. The next problem, limit x tends to 0, e raised to x minus e raised to minus x minus 2 log 1 plus x divided by x in bracket x into sin x. So adjust x, that is multiply by x and divide by x. So it is x into x become x square, x by sin x, and the derivative of x by sin x is 1. X by sin x is 1, not derivative, limit of x by sin x is 1. And so we have the problem e raised to x minus e raised to minus x minus 2 log 1 plus x divided by x square. In the place of x into sin x, we have x square. And then apply Yale hospital rule, because if we substitute x at 0, e raised to 0 is 1, e raised to 0 is 1, 1 minus 1 is 0, log 1 is 0. So we have 0, and 0 square is 0. So we have 0 by 0 form. So apply Yale hospital rule. So derivative of e raised to x is e raised to x, and derivative of e raised to minus x is e raised to minus x into minus 1, minus 2 log 1 plus x, derivative 1 by 1 plus x, and derivative of x square is 2x by Yale hospital rule. Then this is the simplification, e raised to x minus minus become plus e raised to minus x minus 2 1 by 1 plus x divided by 2x. And if we substitute x at 0, then we have again 0 by 0 form, because this is e raised to 0 means 1, e raised to 0 means 1, 1 plus 1 is 2, and this minus 2 by 1 plus 0 means minus 2, 2 minus 2 becomes 0, and this is 0, 2 into 0 is 0. So 0 by 0 form, apply Yale hospital rule. So derivative of e raised to x is e raised to x, and derivative of e raised to minus x is what? E raised to minus x into minus 1 there. So here we have minus sign, minus 2, minus 1 by 1 plus x square. The derivative of 1 by 1 plus x is what? Minus 1 by 1 plus bracket square. That is derivative of 1 by x is minus 1 by x square. So minus 1 by 1 plus x bracket square, and divided by 2x, derivative is 2, and then substitute x at 0. So e raised to 0 is 1, minus sign, e raised to 0 is 1, plus minus minus become plus 2, and 1 by 1 plus 0 square, that is value is 1. So plus 2 divided by 2. So we have the 2 by 2, that is 1 answer. Okay. So next example, limit x tends to 0, 1 by x minus 1 by e raised to x minus 1. If we substitute x at 0, then we have 1 by 0, that is infinity, and here we have 1, e raised to 0 is 1, 1 minus 1 is 0. So 1 by 0 is infinity. And so this is the example in the infinity minus infinity form. So infinity minus infinity is again the indeterminate form. This infinity minus infinity is one of the indeterminate form, but it is not in the form 0 by 0 or infinity by infinity. So we have to reduce these indeterminate forms to either 0 by 0 or infinity by infinity in order to apply the Yale hospital rule. Because when we can apply Yale hospital rule, if the example, if the limit is in the form 0 by 0, so in order to apply the Yale hospital rule, convert the infinity minus infinity form, this infinity minus infinity form, in the form 0 by 0. So in order to reduce this form, we take the LCM as x into e raised to x minus 1 as the LCM. So we have e raised to x, this cross multiplication, e raised to x minus 1 minus x. And then if you find the limit, then e raised to 0 is 1, 1 minus 1 is 0 and 0, and then denominator value is 0. So 0 by 0 form, if we substitute x at 0, we have the answer of numerator is 0, denominator, limit of denominator is at 0. So apply Yale hospital rule. Derivative of e raised to x is e raised to x minus 1, derivative is 0, and the derivative of x is 1, so minus 1. Derivative of minus 1 is 0. And derivative of x into e raised to x minus x, it's simplification. And then derivative is x e raised to x, u into v rule, and e raised to x, derivative of x is 1, and minus x, the derivative is minus 1 by L'Hospital rule. And then limit x tends to 0, e raised to x, again apply L'Hospital rule because we have 0 by 0 form. E raised to 0 is 1, 1 minus 1 is 0, and then the value of denominator is also 0 if we substitute x as 0. So apply L'Hospital rule, e raised to x, derivative e raised to x, minus 1, derivative 0. X into e raised to x, derivative is u into rule, x e raised to x plus e raised to x into x, derivative of x is 1. Then derivative of e raised to x is e raised to x, and derivative of minus 1 is 0. And then substitute x as 0. So e raised to 0 is 1 now. 1. So we have the non-zero by non-zero form. And then 0 e raised to 0 plus e raised to 0 e raised to 0. So this is 0, but e raised to 0 is 1, e raised to 0 is 1. So 1 by 1 plus 1, that is 1 half, is the answer of this problem. So next problem, limit x tends to pi by 2, sec x minus tan x. So sec pi by 2 is infinity, tan pi by 2 is infinity. So we have the infinity minus infinity form. So we have to reduce the form, this infinity minus infinity form, to either 0 by 0 or infinity by infinity. So sec x is 1 by cos x, sin x, tan x is sin x by cos x. And so it is 1 minus sin x divided by cos x, as a cos x as LCM. And then if we substitute x as 0, then x as pi by 2, then sin pi by 2 is 1. So 1 minus 1 is 0. So numerator, limit of numerator is 0. And sin pi by 2, here is sin, here, not sin, cos x means cos pi by 2 is 0. So we have 0 by 0 form. So apply L'Hospital rule. Derivative of 1 is 0, and minus derivative of sin x is cos x, and derivative of cos x is minus sin x by L'Hospital rule. So next is cos 0 is minus 1 will become plus. Cos 0 is 0, not 0. Cos pi by 2, x is pi by 2. So cos pi by 2 is 0, and sin pi by 2 is 1, and 0 by 1 is 0. So the answer of this problem is what? 0. Next problem, limit x tends to 0, x into log x. So x is 0, and log 0 is infinity. So this is 0 into infinity form, and this is again indeterminate form, 0 into infinity. So we have to reduce this form to 0 by 0 or infinity by infinity. If we substitute shift this x to denominator, then it becomes 1 by x. Now we have log x divided by 1 by x. Log x is infinity, log 0 is infinity, and 1 by 0 is infinity. So now it becomes infinity by infinity. We can also shift this in log x to denominator. So we have x divided by 1 by log x. Then we have 0 by 0 form. So either convert this example to 0 by 0 or infinity by infinity. So next is by L'Hospital rule. Apply L'Hospital rule. Limit x tends to 0. Derivative of log x is 1 by x, and derivative of 1 by x is what? Minus 1 by x square by L'Hospital rule. And the simplification is minus x. And if we substitute x as 0, then we have answer 0. Okay. Next problem, limit x tends to 2, 1 by x minus 2 minus log x minus 1. So if we substitute x as 2, we have 1 by 2 minus 2, 1 by 0, that is infinity answer. Similarly, log 2 minus 1 means log 1. Log 1 is 0, and 1 by 0 is infinity. So we have the infinity minus infinity form. And now we reduce this form to 0 by 0 or infinity by infinity. So take x minus 2 log x minus 1 as LCM. So we have log x minus 1 minus in bracket x minus 2. So write it simplification, that minus x plus 2, and then apply the L'Hospital rule. So log x minus 1, derivative is 1 by x minus 1, minus x, derivative is minus 1, divided by x u into v rule, that x minus 2 log x minus 1, derivative is 1 by x minus 1, plus log x minus 1, derivative of x minus 2 is 1 by L'Hospital rule. And then if you substitute x as 2, then we have 1 by 2 minus 1, that is 1 minus 1. Again we have 0 by 0 form. So again apply L'Hospital rule. So 1 by x minus 1, the derivative is what? 1 by x minus 1, the derivative is minus 1 by x minus 1 bracket square, minus derivative of 1 is 0, and then this x minus 2 into 1 by x minus 1, derivative is by using unit rule, x minus 2, derivative of 1 by x minus 1 is minus 1 by x minus 1 bracket square, then 1 by x minus 1, that is v, derivative of x minus 2 is 1 into 1, plus this plus sign, log x minus 1, derivative 1 by x minus 1 into 1, that is derivative of x minus 1, okay, derivative of this quantity, log x minus 1. So don't write this quantity, okay, yes. This is these two terms are the derivative of this x minus 2 into 1 by x minus 1, okay, and then plus this plus log x minus 1, derivative 1 by x minus 1, okay, these three quantities, and then substitute x as 2. What do we have? Minus 1 by 2 minus 1, that is 1, bracket square is 1, so we have minus 1 as the numerator. This becomes 0, this quantity 2 minus 2 is 0, so the 0, and this is what, if we substitute x as 2, we have the value of this quantity is 1, and this quantity is 1, so minus 1 by 2 is the answer. So these are some problems on the Yale hospital rule. So if you observe the next problem, in that it is of the form x raised to x, that is function raised to function, and in order to solve such a problem, to take the log of both sides. So these are the different types problems. These are the problems on the same rule, that is Yale hospital rule, but we have to solve these problems by taking derivative of by taking log of both sides. So if you observe the next problem, cos x raised to 1 by x square, that is function of x raised to function of x. So we will solve these problems of function. If the problem is in the form fx raised to gx, then taking log of both sides. Okay. So if the problem is in this form, that is you have to find the limit of the function of the type fx raised to gx, function x of x raised to function of x, then take log of both sides. So we will solve such a type of problems in the next lecture.